All right, welcome to summer school geometry. For those of you that are just now joining the class for the second semester, welcome. I'm Mr. Patel. This is geometry, and this is semester 2, day 1. In this module, we're going to be talking about trigonometric ratios, sine, cosine, and tangent. And what those three things are, you've probably seen them on a calculator before, is they allow us to understand how the sides of a triangle relate with the angles of a triangle, and how we can use sides and angles to figure out different characteristics about triangles. And so in this first box right here, I'm going to talk about what sine, cosine, and tangent mean, first of all, and how you can use a right triangle to understand what each of them does. We use an acronym or a little phrase to help us understand this. So for sine, we use the letters S-O-H, so. So the S stands for sine, the O and the H stands for opposite over hypotenuse. So what I'm going to do here is I'm going to focus in on angle A, sine of angle A. I'm going to put degrees in there because this angle is measured in degrees, and that's what you put in the sine function right here. What SO means, SOH means opposite over hypotenuse. So with respect to angle A, O would be the opposite. So I'm going to draw an arrow going this way, and I'm going to say that's the opposite. Opposite over hypotenuse. The hypotenuse is this long side right here. So opposite over hypotenuse is A over C. So I'm going to put A over C. For cosine, we use ca. So cosine is adjacent over hypotenuse. So we've got cosine of angle A is equal to, now adjacent means next to, and we already know C is the hypotenuse, so the other side that's next to angle A is this side B right here, adjacent. So adjacent means right next to, adjacent, just like that. And that's going to be B over C because B is adjacent and C is hypotenuse. And then the last one is tangent, and we use the letters TOA, T-O-A. Now tangent of A is equal to opposite over adjacent. So opposite of angle A over adjacent, which is B, so A over B. All right, so each of these is a fraction. Now if we had a real situation with actual dimensions for my triangle, then I could use sine, cosine, and tangent, and these values here would be fractions with numbers in them. Or these angles right here would be whatever angle I'm looking for. Depending on the problem, you'll probably have to use just one of them. Okay, we're going to look at this first example right here. Now, it's just a general triangle, and it asks us to find sine, cosine, and tangent of angle A, and then sine, cosine, and tangent of angle B. So let's first start with angle A. There's angle A. Now we said sine is SOH, opposite over hypotenuse. So 12 over 13. All right, then we got cosine of A. Cosine, ca, C-A-H, adjacent over hypotenuse, 5 over 13. And the last one is tangent of A. Tangent is TOA, T-O-A, opposite over adjacent, 12 over 5. Now let's talk about angle B. If I'm standing at a different angle. If I'm standing at a different angle, I'm going to use the perspective of this angle now. So sine of B, sine is so. Let me write those down here. S-O-H, C-A-H, T-O-A, so, ca, toa. So for so, S-O-H, sine of B is opposite over hypotenuse, 5 over 13. Ka adjacent over hypotenuse, 12 over 13. And tangent is opposite over adjacent, 5 over 12. There you go. So now let's look at this right column. It's called inverse trig. It's kind of the opposite of this guy right here. I use inverse trig to try to figure out what is the angle itself if I don't know it. So right here, I've got this angle down here. And I see that I have opposite and the hypotenuse. So for this one, I have OH. That's going to be sine. So I got sine of x equals 4 over 5. Opposite over hypotenuse, 4 over 5. And now what we can do is we can use an inverse trig function to figure out what our angle x is. So what I'm going to do here now is use an inverse trig function. What that means is I'm going to use sine inverse. And if I do the inverse, that means that these two items, x and 4/5, have to switch spots since I did this inverse function. We're inverting this function, and I'm going to move the x over here, and I'm going to put the 4 over 5 in here. So once I do that, I need to go to my calculator real quick. And what I'm going to do is I'm going to find sine inverse, sine with a -1 on it. And inside the parentheses, I'm going to put 4 over 5, just like I wrote. And in the settings, we're going to have to change to degrees mode. Make sure you have degrees highlighted in green. And now if I go back to my screen, notice how now I have 53.13. That's the measure of that angle. So here I'm going to put x is equal to 53.13 degrees. That's that angle right there. Here I got angle x. I have adjacent over hypotenuse. So this is AH, ka. So cosine of x is equal to 7 over 9. And I'm going to do the inverse cosine and put 7/9 inside the parentheses, move my x out. And let's go back to our calculator. We're going to do inverse cosine. Inverse cosine of 7 over 9. There we go, 38.94. So here I have x equals 38.94 degrees. And that's the measure of that angle in there. All right, last one down here. We've got angle x, opposite over adjacent. This is OA, so TOA, tangent is what we're using here. So the tangent of x is equal to 7 over 14. And now I use inverse tangent. So tangent with a little -1, put 7/14 inside of there, and then put equals x. So now real quick, let's double check this. We've got inverse tangent of 7 over 14, which is 26.56. And x equals. There we go. There's your angle measure. Okay, so once again, just to recap, we're talking about sine, cosine, and tangent, so, ka, and toa. And you can definitely use your calculator. Just go to desmos.com/calculator and you'll be able to use those three to help you solve the problems. So now go ahead, go back to Canvas, click on the module for today. And if you have any questions about the assignment, you can email me at any time if you have any questions.